This is the second episode in the equals mc2 Algebra for the Summer series. Okay, let's say we have this problem. Ed lives 155 miles east of Will. At 9 o'clock a.m., Ed drives west towards Will's house at 15 miles per hour. At 10 o'clock, Will drives east towards Ed's house at 20 miles per hour. When and where would they meet? Some people might try solving this using graphs, but we're going to show you how to do this using algebra.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, lithium, beryllium, and barium. Isn't that interesting? I hope you're all paying attention. There's going to be a short quiz later on. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, red, and zinc, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
All right. So let's try and solve this problem using a diagram first. And Will is on the west, and Ed is on the east. So E stands for Ed, and W stands for Will, and he's on the west. And Will will call his position initially 0, and Will's position is 155.
So where will they meet?
So where will they meet? We'll call this distance
We'll call
D.
this D.
Goes,
we'll call the distance D.
D goes from 0 to 155.
D goes from 0 to 155.
Now we could have an unknown T.
Have an unknown T.
So T is the time they meet. It could be 9 o'clock, well, obviously not. Somewhere, it can't be 10 o'clock. It's going to be 11, 12 sometime. Let's call it T. When they meet at time T, it's not the time that they've driven. It's the time that they meet. And it'll be 9, 10, 11, 12, 13, 14, like that. At the meeting time, the position of Will equal the position of Ed, just using E and W for Will. So, well, Will's position is initially 155 miles.
So Will's position
and he's going in a negative direction. He's going east to and he's going at 20 miles per hour. The time that he's traveling is really T minus 10 hours because he starts at 10 o'clock. So that's his position as a function of time. And Ed's position, he starts at position 0, and he goes in an increasing direction at 15 miles an hour for a total of T minus 9 hours. He's actually starting out an hour earlier. 75 miles. Not quite halfway, because halfway would be a little more than 75. Okay, another way to do this problem is to make your unknown be D, the position. So let's just draw, sorry for that. Okay, here's Will on the west side, and here's Ed on the east side. Ed's position is initially 0, and Will's is 155 miles. Is going at 20 miles an hour, but he starts at 10 o'clock, and Ed is going at 15 miles per hour. He starts at 9 o'clock. They meet at a position somewhere here, and let's call that position D. So the time that Will meets Ed will equal the time that Ed meets Will. So let's set up an equation for these two times. For Will, he starts out at 10 o'clock, and he travels a distance of 155 minus D, but he's going at 20 miles per hour, so the time it takes him to get to D would be this number of hours. Add that to 10, and that's the time that Will meets Ed. Ed, of course, starts out at 9 o'clock, and he is going in a positive direction, so the time he travels is D over 15, so 9 plus D over 15. Now, I'm not going to go through the arithmetic of solving this equation. It's pretty simple, but the solution comes out to be D equals. If you wanted to, you could solve for the time by just saying that the distance traveled is equal to the speed of Will times the time. And that's, since you know the miles, you can get the time. Okay, thank you for your attention, and that's 2 ways to do a problem.